Right, hopefully we can see the slides. Okay, so we're going to talk about immich today. I believe that's how it's pronounced. So this is the agenda, roughly. First of all, we'll have a discussion about what it is and why you might want to use it. But because this is the computing forum, of course, we want to dig a little more what's going on behind the covers. So we're going to have a look at the architecture, we're going to look at the containers, we're going to look at the networking, we're going to look at the AI features. It's got some neural networks in there. And as we happen to be discussing, I'll also touch on how I'm personally doing backups. So what is it? Well, very simply, it's an open source photo management system, rather like Google Photos. So it's not meant to be a photo editor. It's meant to be a photo organizer, very much like Google Photos. So why would I want to use it? Well, with immich, because it's open source, you can host it on your own servers. So you don't have to make use of Google or some other providers. Two problems, or at least two problems you might have with using a hosting platform like Google Photos. One is if you've got a lot of photographs, you're going to end up paying for storage. And to be honest, you may as well take that money and put it towards a hard disk, which you install on your home network, rather than, keep paying some money to Google. And of course, the thing with Google is particularly actually more so with Gmail. Of course, Google look through all your emails, looking for various things. And then sometimes, again, it's a privacy. What's your level? Do you want Google to be looking at your photographs? Now, another reason why you might want to do this is that if these hosting providers can change at a drop of a hat sometimes. They might do an upgrade which you don't like. Now, Google is particularly bad for this. They may well release a service, have millions of people using it, and then they'll, give you a month's notice and actually discontinue the service. So you can get stuck if you rely on a hosting platform. Yeah. Having said that, I don't think it's going to happen with Google Photos, but it's one of the reasons why you want to host things yourself. So it's provides the usual photo timeline of all the pictures you've taken, but it also allows you to search for places and objects. It's got a map view, so you can see where your pictures have been taken. You can search for people. So it has got some face recognition built in, and we will talk on a little bit on how that works. And you can search for objects. So it's got object recognition built in. So all your pictures, you upload your pictures, and immich will identify faces and identify objects, so you can later do searches on them. You can sort your pictures into albums. It is multi-user, so you could share access to your album with family members or whoever you want to, really. And you can share albums. So just like Google Photographs, if you've taken some pictures of your favorite U3A event, you can just share a link with your friends and they can come in and view just that album. And there's phone apps available, both Android and iPhone. They allow you to view the pictures on your device, but also auto-upload any pictures you've taken. So you can take your phone out, take lots of pictures, and they'll automatically get uploaded to immich, and so on and so forth. So rather than the list of features, I thought we'd jump straight into a demo and have a play. So, if you've got any questions about it, do raise it. Now, they do say don't do demos, don't they? I was going to use this site, which I've got there, demo.immich.app, and about 10 minutes before we started, it was down because about an hour ago, the next major version of immich was released. And I think they're going through the process of updating the demo server, typical way. So I will actually be sharing my personal photo album today. So hopefully there's not no too many embarrassing pictures there to look at. I'll try to be careful. But right, here's a warning. And this is a cut and paste from Immich's website. So this project is under a very active development. So expect bugs and changes. Do not use it as the only way to store your photos and videos. So don't blame me if you use this and you lose your pictures. Having said that, I've been using it for some time now and I found it really, really good. This is a screenshot just in case the demo works. So we've got a web page, immich.plord.co.uk. That's where I host my pictures. And of course, there's the equivalent mobile phone app. So let's look at my pictures then. So, feel free to, interrupt, unmute yourself and just speak. It's probably easiest as we go through this. So this is Immich. You can say I'm actually hosting it on my personal server, which is just next to where I'm sitting, but I am sharing it over the internet, and we will talk how the networking aspect of this needs to be done. So Immich gives you it's like a timeline of pictures down the side. You can scroll up and down, and it gives you an album view. So you can put your pictures in various albums. I don't know. Let's have a look at some wedding pictures. Why not? And it does facial recognition. So you can click on the information, and you can see what people have been identified on this, which is quite nice. And then if you have, let's pick another album. Why not? What do we want to look at? Glastonbury. Yeah, we like Glastonbury. You've also got a map view, so you can actually see where the picture's been taken, zoom in and zoom out. So you got a map view, you've got a view of people. So that's one of the things I do like, it does support 360 pictures if I can find some. Yeah, here's one. So this is a 360 picture, and you can scroll around. This is a festival site being built. So that's what you can see. Again, you can see the location there. Person recognition again. What other features is notable? So we've got we can explore by people. So you can select a person and you can find all the pictures with that person in it. Some more wedding pictures. Yeah, so you can see the different people who are in this picture. And you can search by location. Oh, I don't know. Let's look at Amalfi. You can see pictures based around a given location. But also, and then here's the nice thing, is you can do a search by text. So you can do things like you can see I'm doing it for dog on beach. And you'll find all the pictures of dogs on beaches, which is again quite nice. And you've got a nice little filter here with a much more sophisticated search. So you can look at, do a search for beaches with particular people, and so on. So yeah, speak up, David.
Yeah, was that based on searching the EXIF attributes, or was it an AI function?
Which one?
Sorry, the dogs on beach.
That's an AI function. So I mentioned earlier, it does a search for objects in pictures. And when you upload pictures, it gets processed by a neural network that enables object identifications in pictures that enables this search. So the pictures I've uploaded have already been processed. It knows pictures of beaches, and there are pictures of dogs, and there are pictures of people and places and so on. And we'll talk some more about that later. But
I don't know whether to be impressed or concerned.
well, you see, Google Photos is going to be doing this anyway, but of course, all that's on the Google server, and you might be concerned about that. But this is running on my server, which is just here, which is, completely under my control. So I'm happy to do that with my pictures, my neural networks on my server. I'd probably be less keen on this if it was a server managed by a third party.
Right. Okay. Thanks.
I suspect that's probably all I want to share at this point. Any sort of questions about features of the application before we talk some
Uh,
more about under the covers?
Share.
Pete, oh sorry,
Yeah.
yeah,
Go ahead.
Peter, it's Neil. Yeah, I've just this on this places thing that you've got. Did it generate some of these titles? Because you've got a Lou with Argosy
Yep.
on it, and it actually it generated that, or
Yep.
that
So
was
it's a good point. So we can have a look at these pictures, and it's got the locations here. And there is
okay.
so when you take a picture, particularly on a phone, there's a setting on your phone that embeds the location, the GPS coordinates in the picture itself. And of course, immich will read that and it can put the picture on the map. But it's also got a feature which is to do the reverse of the location, the latitude and longitude, back to place. It's called reverse geocoding. So we got, pictures of Amalfi. I mean, these pictures have got embedded latitude and longitude, but immich has taken that latitude and longitude and converted it to the nearest place. And one thing I didn't share, actually, we've got a map view as well. So you can see a map, see where all your pictures are on a map. You can zoom around and, find the pictures at particular places on the map.
If you're uploading something old, presumably that's not the case. If you're uploading something, say that you produced something did on a camera, it hasn't got any of that information at all. Unless, is there any way of encoding anything like that into
Yes,
it?
I mean you can do. You can add a location or edit a location. So this is a good case. This is from my camera in the garden. It's got no GPS on it. It has got a timestamp, which is useful, but it doesn't have a location. So you can actually edit the location and add it in if it's missing. But yeah, if you're using a camera without a GPS chip in it, you're going to have that issues. But when I was using SLR cameras, my SLR camera had a GPS chip in it. And that was, I don't know, 20 years old or something. Was someone else talking while
Yeah,
Neil was talking?
Peter, it's Alan here. Were you going to cover the sharing capabilities later, or?
Yeah. I'll do it now if you like. So we've got some sharing options here. Let's do it. So we've got albums, we've got a U3A study, and then we can share it, and we can create a link. And we've got various options with the link, so we can add a password if you wanted to. And you got to choose whether it's individuals, whoever is sharing this can download the original and so on. And you create a link, and you've got this unique link here, which I'll do it and paste that link in, which you can share with your friends, and they can only see that album and nothing else.
Brilliant. It's incredibly richly functioned, isn't it?
Yeah, it's not too bad. I've lost where I am now. It is under heavy development, so some things are, not quite perfect yet, but generally I must admit I really like it, and I particularly like it that I can run it on my server and not a Google server. And you can see down here, if you can see it's storage plate space. I'm using 413 gig of 1.8 terabytes. So, I can add as much storage space as I like without, buying some storage from Google or someone else.
A couple of quick questions, Peter.
Yeah, go ahead.
Yeah, it's right here. Can you run it on a NAS, or has it got to be a proper server type computer?
It depends on the functions. So some NASs allow applications to be added, and some don't. We'll come on to it in a minute, but the most common way to run this is with containers. In other words, with Docker. So some
Right.
NASs will support containers, and if it does, there's a fair chance you can fire this up.
Okay. Second question, when you're in sharing mode, that's giving people on the outside access, presumably into your system and into your server.
Yes.
What's the security
Well, you
setup?
saw when I shared it, there was an option of passwords and such like. You are trusting that the this application doesn't have any bugs in it. But the way you'd actually, and we will look at the architecture in a minute, the way you would do it is you would share on the internet the immich application, but constrain access only to immich. So if there is huge security bugs in this software, all they could do is see some other pictures on your inside immich, not access your server directly. So your server will be protected, but you know, I've never seen any security bugs like that though yet. But of course, one of the advantages is open source, so you can, you know, if you're able to, you can look at the source, but more interestingly, you can look at all the previous bugs to see what's been reported by other people.
Okay. Do you have to have any special configuration in your home system to cope with it?
In terms of networking,
Yeah.
yeah, we'll talk about networking, and
Right.
yes,
Okay.
we will have to do that. Yeah. So any other questions on features of this particular application before we start delving a little bit more detail under the covers? Okay. Well, do speak up if you want to talk about anything else in here. I suspect we're going to have plenty of time today. All right, so let's go back to the slides. So this is the architecture of the system at a very high level. So we've got what they call the immich server, and this consists of a number of components. We've got the API controller, which gives you access to other components. We'll see this in a minute. We've got the core function of the application, and that's managing, you know, all the metadata of the pictures and the locations and so on. And we've got this back-end server repositories. We've also got jobs. Now, what happens is that external applications can access this API. And what we've got so far is a web application. And that's what we've just looked at. You know, you've got a web application, you can browse pictures. And what that's doing is lots of JavaScript code, which is just calling this API to, you know, find pictures and find locations of the pictures and so on and so forth. We've also got the mobile app coming into the API. And we've also got a command line tool coming in at the API. And the command line tool doesn't, you know, it's not particularly that interesting, but it's got some features. For example, it will do bulk imports of Google Photos into immich. So a few nice things, you know, instead of doing one at a time. Now on the back end, we've got a separate process here, which is the machine learning part. And that is a component that's got neural networks in it that does things like, you know, facial recognition and object detection. And we've got the file system. Now, the file system is where the photos are actually stored. Now, you need to know this if you're looking at backups here, because this file system is a thing that you really absolutely need to back up, because that's the original untouched photographs. You at least back those up. And we've got a Postgres relational database, and that database holds, you know, all the metadata the EXIF extracted information, where the thumbnails are, and so on and so forth. And a last component we've got here is a thing called Redis. Redis is one of these non-relational database, and it's like a name value pair database. And in this particular application, we're using Redis as a queue. So if, for example, you're doing a bulk upload of pictures, what we want to do with those pictures, we want to take one at a time and do facial recognition, object recognition. So we put all those jobs in a queue, and then we do execute those jobs one at a time. So because we got Redis, if we were to take down the server and restart it, the queue of jobs will just carry on running when the server comes back up again. Yeah. It's just good design of the application. So this is what it sort of looks like. We've got a main server, we got some back-end machine learning, we've got a back-end relational database, and we've got to open up our API to external applications. So moving on to a network view of the same thing. This is my personal home network. So what I've got a Orange Pi 5, which is one of these little tiny single board computers, got a powerful one, and I've got plugged into that 2 terabytes of SSD cards. So it's just a little card plugged into it. And of course, we're running the immich server. We got the command line tools running, and I took the labels off, but we've got the relational databases running. We've got the machine learning stuff running, and we need to expose this in the right way to the network. Now, this is where it gets a little bit complicated. So for my personal server, this Orange Pi that I've got running in the cupboard next to me also hosts other applications. So I've got a web server, which is my web server, plord.co.uk, which consists is actually WordPress based, but it's got lots of HTML pages and such like. And I've got a Jitsi server, which is an experimental web conferencing system. Hopefully at some point we'll get around to testing this because it's a possible alternative to Zoom. Now, what I've got front end in these is a little piece of software called nginx, which is a generic web server, but it can also take inbound requests and direct them to the right backend server. So these are actually labeled. I've got plord.co.uk, which is my web server. I've got meet.plord.co.uk, which is the web conferencing server. I've got image.plord.uk, which is my photo server. And this guy here will direct the request to the right backend server. What this also does, it hosts my security certificates, so we can use HTTPS://. So it's a little bit complicated because it's got other stuff running, but this is a fairly standard layout. Front end, all your web type applications with this guy here. Now, I've got I've now got a fiber connection coming into my house, and I've got this router. And this router also contains a firewall and such like. And then this here is, I've got a piece of fiber going out into the street outside, and that's obviously connecting to the internet. So what we want is people, especially myself, who's on the internet, I'm at a festival somewhere taking pictures. I want my phone to connect directly to my immich server. So, we've got a mobile phone app and a browser that needs to come in to my router. My router's got to pass that through to this proxy guy, and this one here has got to pass it on to the right backend server. So the way all this works, and after this slide, I will pause. Okay, so this nginx will be listening on port 443. Now, 443 is a standard TCP port for HTTPS, in other words, secure encrypted web traffic. And the internal IP address of my Orange Pi is this one here, 192.168.175.12. And that's only valid on my local network. It's not valid outside of the firewall. So what we need to do is to map inbound requests coming into my router to this IP address and port number. Now, the public IP address of my server is there, 46.37.104.156. This is unique in the world. It actually belongs to me. That's my address. No one else is allowed to use it. So you could, all right, in your browser, you could type in https://46.37.104.156, and that would get to my router. Obviously, it's not very convenient. But we need to configure this router to pass through this port number. Now, this is the sneaky bit. In this router, I've got some configuration, and it's known as port forwarding or virtual servers or something like that. And you'll see here this rule number 4, external port 443. I'm passing it to the internal IP address 192.168.175.12 port 443. So that means whenever someone on the internet connects to this IP address at port 443, my router will then just magically map that through to here. So it's passing through that. Everything else will get blocked. So if you try to access port 444, no, you're not going to do that. But port, 200 or whatever, the firewall here will block that. Only port 443 will forward, and it'll only forward it to my internal instance NGNIX there. But there's another step that's needed here. We also need to give a name to my server. No one, especially me, is not going to remember this name. So what we have, so far what we've talked about, we can access https://43.37.104.156, and that will actually get you to this guy. That will work because HTTPS by default is port 443. But another last step is we need to give some names to the server. So I've registered my domain, plord.co.uk, in a domain name service, and this is the editing for this. So I've said that plord.co.uk is my IP address. I've also said that immich.plord.co.uk is the same IP address. I've also said that meet.plord.co.uk is that IP address. And so when you fire up your web server, you type in https://immich.plord.co.uk, your browser would go to the internet and look up that name. You get a conversion to the IP address, and then your browser would connect to my router would forward it, and the NGINX would then forward it to the image server, and then you get a response. So lots of layers, but that's what we're trying to get to. A browser, full domain, goes through my firewall onto my little server in the cupboard. Any questions?
So is that sub-hosting you're using?
Yes, it's just different A records.
Oh, okay, but you're doing the you're doing it at the DNS level rather than running a function within the web server itself.
Yeah, so I've got an account with a DNS provider called Namecheap, and I own the domain plord.co.uk. and I've asked Namecheap to manage that plord.co.uk domain. And so they give me a little admin screen, this admin screen, and I can type in all the DNS records for anything that ends in plord.co.uk. And in this case, I just need a record to resolve immich.plord.co.uk to an IP address.
Is that sort of future looking, so you could perhaps move some of these services off to a completely different server stroke?
Yeah. If I wanted to move my image server to a hosting provider, I could absolutely just change the IP address here to point to the hosting provider. So it's the level of redirection, if you like.
How does NGN IX know where to send it?
I can show you actually. So in the configuration of this, what you do, you configure this that says if the request is going to immich.plord.co.uk, then connect to the image server. If it's going to meet.plord.co.uk, then go to my video conference server. If it's only going to plord.co.uk, then go to the web server. So this has got a little bit of configuration that looks at the name that you typed in on your browser. It's looking for this name here.
Okay.
So you can see what I'm trying to do today. I thought we'd talk about immich as an application, but of course we're scratching the surface and we're covering lots of different aspects of it, which I think are interesting. But
So what's the functionality from the phone end? You're at Glastonbury.
Yep.
You're taking thousands of pictures because that's the sort of chap you are.
Yep.
How do you then interact? I mean, technically, you've shown how you interact with this.
Yeah. So if we go to the picture which I had, so this is a screenshot of the application. So I don't think I've got an easy way to share it today, but so you can install an image from the Play Store or the iPhone equivalent, and it allows you to browse through and look at your pictures in exactly the same way as we saw with the web version. Obviously, it's a bit smaller, slightly different icons and such like. But you notice here it's got this little upload to cloud. And what you do is you configure the phone app that says whenever there's new pictures on the phone, then upload it to the server.
Oh, wow.
So if you're in the field taking lots of pictures, you'll see additional pictures appearing in immich. So it'll automatically do the uploads for you. So that's its main additional function that you actually don't get with the web version. It's automatic. So it's a bit like Google Photos. Google Photos is exactly the same thing. Take lots of pictures on your phone, it'll automatically upload it to the server. And there's settings, don't upload if you're not connected to Wi-Fi, or also upload your screenshots, and there's quite a lot of settings there.
Thank you.
Right. So unless there's any other questions about networking, I shall proceed to processes and containers.
I suppose one question, assuming there is somebody else in your house, any experience from a bandwidth perspective? If I mean, we don't have this, but if you've got somebody trying to stream a film at the same time, while you're uploading all these photos and stuff, and any experience from that perspective?
I've got a fiber link now, so I don't care about bandwidth. But yeah, I would say most people are going to be doing pictures most of the time, and pictures are comparatively small compared with broadband bandwidths these days. But yeah, if you're taking loads of long videos, those will take a bit of time to upload, and you may choose to set the mobile phone app to only upload when you're on Wi-Fi. I'll be less concerned about your home network, but more concerned about the data usage on your SIM.
Thank you.
So processes and containers. So we talked a little bit about the architecture. So we need these components working. We need the immich server working. We need the Postgres relational database running. We need Redis running. And the easiest way to do this, like always, there's lots of ways to do it, but the easiest way to do it is just with containers. And one of the easiest containers to use is Docker. And so if you want to deploy this yourself, these are the steps, and it really is this simple. You download this small configuration, Docker Compose.yaml, and Docker Compose describes these components that we want to run and also what networks connect them together. We create an end file, which determines things like usernames and passwords and things like that. And all we do is run Docker Compose up. And what that Docker Compose up will do is it will read the configuration file and then start several containers that represents the application. And that's it. That's what you need to do to start up all the right processes. This is what it looks like. And we can actually have a look at it live if you like. Docker Compose up. And what it'll do, it will download the container. We talked about container images last month. It will download container images if they don't exist. And then these images, these containers will be started. So we've got, a machine learning container, we've got a Postgres container, we've got the server container, and so on. And that's what we need to do to start it up. Tell you what, let's actually try it. If I can get the right share. Okay, hopefully you can see this. So we can do Docker PS to see what containers are running. And we can see we've got this immich server running. We've got the machine language container running. We've got the relational database running. And we've got this name value pair that does the queuing. And these have different TCP, networking ports open. And that's it. And actually, let's do it. Let's stop our server. So we can do Docker Compose down, which stops our containers. And we can do our PS, just got this unrelated application running. And we can start it up, and you can see, well, the images were already downloaded, so all I need to do is start the containers. We can see they're already created and started, and we can see they are immediately running. So actually running this kind of sounds complicated, but if you make the switch over to some sort of container management, I'm using Docker Compose in this case, then it becomes so much easier to do. Any questions on running these containers? One thing you can do is have a look at the logs for the containers. Docker logs and immich server. You can look at the logs if you wanted to. Now, of course, you can have, graphical user interfaces for this, but, despite what Peter was saying earlier, this is, command line solves all the world problems. Any other questions about deploying this or running these containers on your server? Okay, let's stop. Oh, sorry, John.
You're using a Mac, or are you doing this on Linux?
What you were seeing, I was logged onto my Linux server.
Okay. For the lesser mortals who hope that their systems will continue to run Windows 11 or whatever it turns out to be, and are unlikely to be nudged in any other direction, this all seems like a very big fag. Am I missing something? In Windows, you just type immich and off we go.
And well, remember you're running a server here. You're not running a client application. So typically running client applications is as you describe. You just run the application. But in this case, we're talking about how to run a server, and you actually have to have, usually a piece of hardware that's going to run 24 hours a day. That's not your desktop. That's running all the time so that your friends across the world can kind of see your pictures at any time. So yeah, I mean it does require a server, which is not your desktop, and I use a little tiny single board computer which I purchased and spent 10 minutes installing and then run this command to start it up. So it really does take a few minutes. You saw me starting it, so it's I wouldn't describe it as a faff, but it's not the sort of thing that you'd run on your client, on your workstation, on your desktop. This is a server type application that we're talking about.
I'm interested primarily. At once upon a time, I used to use Adobe Lightroom as my main photography management system, which, as you know, is a client. I don't anymore. I gave up Adobe stuff, but this is not the alternative to Adobe Lightroom.
No, this is a alternative to Google Photos. It's a photo organizer and sharing applications. It's not an editor.
Lightroom was that too.
Yeah, but the editing features are very, very lightweight. Okay, so let's go back to my slides. Here. Sorry, I couldn't find it for a minute. Right. So these are the components, although I hear what you say about it's a bit of a faff, but actually does take it just a few minutes to start up the server. And this is what the Docker Compose file actually looks like. Now, you just download and use it, so you don't need to know the contents. But I thought it'd be interesting to this group to share the sort of things that's in it. So we've got basically a list of services. We've got the immich server, and we've got the container name. We've got the image location. We talked last month about container images, and they have this URL type syntax to download the image. And we've got things like volumes created. We've got TCP port numbers exposed. And in particular, we said that this image server depends on relational database and Redis. So this means that this one component of your application won't start unless the relational database is already started. So although this application consists of several small components, it's organized as such so that they start up in a very consistent state connected to each other. So we've got the server there, and in a similar way, we've got the machine learning component, which is actually very different technology. So this is lots of Python and such like. Again, that's got an image that we download and then create a container from the image. And it's got some volumes. And we've got our Redis database, which is this name value pair, which we're just using for a queue. And of course, we got our relational database, which actually stores all the your album formats and so on and so forth. The images themselves are not contained in the database; they're external. So we need database username and passwords and such like. And one thing about these containers, they will usually have a health check there. Now, what that means is that should the database, in this case, fail for whatever reason, I don't know, it could hit a bug or, someone could accidentally kill it or whatever, then the Docker Compose will actually automatically restart it. So it'll constantly test, are you working? Are you working? Are you working? No, you're not working. I'm going to go and restart you. So Docker, these composes, like Kubernetes that we talked about last month, is quite nice. It does maintain a consistent view of this running application on your server. Okay. Anything else about deployment? So we've talked about network requirements because I'm running it on my home server. We've talked about containers, and they're actually quite easy. You just download the Docker Compose and run a Docker command, and then up comes your application. And we've also talked about, what this application is and how to use it and so on.
Will you be talking about how the image files are actually stored, structured?
Let's hold that when we talk about backups. Okay, let's move on to the machine learning. So we've got this one component of immich, which is machine learning. And as we said before, there's a few cases of machine learning this application's got. Right, we're on to big, long names now. So we've got a neural network model called contrastive language image pre-training, just called CLIP. And this is from OpenAI. It's an open source neural network model. And what that will do is it will take images and descriptions, and when you upload pictures, it will figure out what objects are contained in it. And we'll talk a little bit more about how that works. So this neural network has been pre-trained with, tens of thousands of images and their related text descriptions. And this is the way it works. It doesn't work quite the way that you might expect. So this neural network, as I say, is pre-trained with images. In this case, we've got a picture of a dog and text descriptions. And this is the pre-training. So this is happens before we download the model, if you like. And the text descriptions go through a text encoder, which is the neural network. And the image also goes through an encoder, which is again another neural network. And what these produce is a vector. Now, a vector is a list of numbers. But these list of numbers for this particular text and picture combination is not arbitrary, and they're quite concise. The neural networks encode the text and pictures such like similar pictures have similar vectors. So if you pick lots of other pictures of dogs, they will have very similar vectors, and we're just storing in the neural network these actual vectors. We're not storing the pictures, we're not storing the text, we're storing the vectors. All pictures of dogs, every single picture of dog will have a different vector, but they will be very, very similar. A picture of a table would also have a vector, but it would be very different to a picture of a dog. Now, when you upload a picture to immich, this processing is done on the picture. And so your picture is converted to a vector. And that vector is stored in our database. So we've got a database of vectors of your own pictures. That's another piece of information. Now, when you do text searches in the application, what actually happens is you type in, dog on beach or something like that. That text is converted to a vector, and then it's looked up in the database and looked for similar pictures with similar vectors. So you type in a description, we do this text encoding, and then we convert that text to a vector, and then, then we find all the pictures in your database that you've uploaded, which has a similar vector. Hopefully that makes sense. It's non-intuitive, but to do searches, you type in the text, that converts to a vector, and then we find in the database all similar vectors, which then returns all the pictures that matches the description that you just searched for. So we're not storing in the data, weirdly, we're not storing in the database all these searches, all these descriptions of images. We just got stored as vectors. Interesting way to work, I thought. So the other neural network that we got is for facial recognition. And in fact, that's broken down into two parts. We have to do detection. So if you've got a picture with lots of faces on it, the first part is we're extracting the faces from that picture. And then we've got second phase, which is doing recognition. And in this case, we're using a neural network from Deep Insight. And again, these are open source. So you can go on the web, you can read some more details. And so what these neural networks do is, first of all, they look at a picture and find all the faces in it. So they return bounded boxes where on the picture are the faces. And then we do a second, very similar to these objects. We take the faces in that picture and convert it with a neural network to a vector such that similar faces have similar vectors. You know, take two pictures of the same person, they're not going to have identical vectors, but they're going to have very, very similar vectors. And in fact, these neural network models use a number of different techniques to categorize or convert faces to these vectors. And I've listed them here. You can go on the website and find out what they are. And so the key point here is that the same person has similar vectors. Now, once we've got a database of these similar vectors, then we can go into immich and say, this person with all these similar vectors is Peter, and actually attach a name to this group of similar vectors. And these neural networks, you can go onto your GitHub and you can download the model and play with it if you want. You know, it's all open source. And so it uses a number of techniques to do image recognition. So first of all, it just looks at dimensions of the face. And this neural network will convert that picture just to 4 numbers, you know, width and height, you know, X, Y, X, Y. But there's another neural network that will look at the face and it will look at poses, you know, which direction your face is looking for. And that turns out to be 7 numbers. And the neural network will look at key points in your faces, you know, eyes, nose, and mouth, and that gives us 10 numbers. And then we go on in more detail, different techniques to map this face to this vector, this list of numbers. We have more detailed landmarks, you know, eyebrows and eyes and shapes of noses and shapes of chin. We've got the mask, the whole shape of the face. We've got a 3D mesh in low resolution. We've got a 3D mesh in high resolution. And all these techniques will take this picture, these faces from the pictures and convert it to vectors. And as I said, the key thing is that similar vectors, similar faces have similar vectors. So we can go in to immich and we can find, categorize photographs containing pictures with similar vectors. Hopefully that's sort of making a little bit of sense. So we have some configuration for these machine learning components, and I'll just dump to the screen here. So we can actually just disable it if we don't want to do it. From a functional point of view, this finding objects in pictures is called smart search, you know, and it uses this clip neural network. And we've got the name of the neural network model. And when you fire up immich for the first time, it actually downloads this neural network from, you know, from GitHub, I think, or maybe from Hugging Face. And then it will run that neural network and apply that neural network to all your images so that it can do the object detection. And actually, it uses this object detection for duplicate. So if you've got these object detection, you know, dogs on beaches or whatever it might be, that's going to be converted to a vector, and you'll say virtually identical vectors are going to be duplicate pictures. It might be different resolutions, you know, it might be you know, different exposures or whatever, but from an object detection point of view, they could be very, very similar. And you see here, we're actually putting a number in here for duplicates. What is the actual difference of these vectors? How close do these two vectors need to be before two pictures are deemed to be identical? So it's not. Yeah.
I'm fascinated by the level of effort that goes into recognizing different faces. Presumably, that's because that's important to us humans. But you talked about this being a pre-trained model and it can recognize, for example, a table.
Yes.
I assume it's not going to that level of detail with a table. It's going to be a more simple.
So we got two different models. We're using clip to identify fairly generic
Right.
objects.
So my question was going to be,
Yeah.
supposing you were a pigeon, going back to your maximum distance, maximum detection distance, supposing you were a pigeon fancier, and for you being able to differentiate Frida from Jim, from John, from all the other pigeons that you've got was something important to you. Can you use this to get to that level of?
Not right now. So we got two separate neural networks. We got this clip, which is being pre-trained on tens of thousands of generic objects which you find in everyday life, tables and chairs and computers and printers and beaches and trees and such like and so on. And you can actually look at the model and actually get the list of all the training data. So it knows about these objects, common things you'll find in photographs. And then we use that pre-training to judge our personal pictures in our database, spot those objects and convert them to vectors so we can then do a search on them. And then we've got a second neural network, which is the facial recognition. And this has only been trained specifically for human faces. Yeah. So this object this neural network has been trained to look at distances between the eyes and the nose and the shapes of the faces and 3D mesh, all the stuff that we talked about has been pre-trained on faces to look at those key numbers, and then actually we use it to convert faces in our pictures to this vector based on this training of generic faces. And we're actually using a model called Buffalo. Nope. In our configuration here. And again, you can go and look at these models and see how they work if you're particularly interested. I mean, it's nice that immich uses open source neural network models because you can look in and you can see feasibly potentially what you could do. You could take one of these models, Buffalo, let's say, and you could train it yourself on all different types of pigeons. And you could say the key aspects for pigeons is, the beak length and, the colors of the feathers and so on and so forth. And then once you've got a generic model, a pre-trained model that can recognize different, takes numbers from different types of pigeons, you can store this in and then actually get immich to recognize your pigeon. So yes, you could do it, but you'd need to have a model which is pre-trained to know about pigeons. And again, for the facial recognition, we got these distances, how close do these vectors have to be the same person? So if you find in practice that, perhaps you're too, you keep getting confused with your sibling, two faces which, we could tell apart, but, these algorithms would say actually these two brothers and sisters are, got very similar vectors. You might want to reduce the distance so that immich has got a better chance to distinguish these two people apart. Okay, anything else on machine learning? Because that's about as much detail I plan to go on.
Yeah, sorry, Pete. It's Neil.
Yep.
With something like facial recognition, and you referred to the 3D mesh things, but what happens about faces? I mean, all of your imagery was for front-facing faces, but a lot of the images you'll have will be sort of partial profile or something else like that. How good are these systems at dealing with things which are not direct? Are they? Have you found that they still recognise the person if it's
I found they're extraordinarily good.
Right.
So if we just take a person. Let's see if we can find some examples here. Probably a poor example here, but yeah, okay, so here's one.
Yeah.
So he's sort of sideways facing here, but he's still recognized.
Right. And the guy that's in strict whatever they call that,
Yeah,
facing to the side.
he's not been recognized. It might be
He
because
hasn't recognised.
he's
Yeah.
cut off. Yeah. So it's not perfect, right? But it's actually
No.
actually
Oh, was
surprising.
it? I mean, the other bit was when they're further away in the image, does that make it, do you find it's pretty good or as good, irrespective of how small the actual image they're working with is?
I find it astonishing, to be honest. You can see, I'm just flipping through here.
Yeah.
And these are relatively small faces, but it's getting them right.
Right. Okay.
I haven't put names on everyone.
And in terms of retraining it, you mentioned this thing of it. Have you found you've had to retrain it much at all? I mean, it
No,
sounds
all I've been doing, these neural networks have been pre-trained. The facial recognition has been pre-trained to recognize human faces and work out all these different distances and shapes and meshes and so on as we saw. And then our own personal pictures will go through that neural network. The neural network will output all these numbers, distance between the eyes and shapes and that sort of stuff. We put that in a database, then we'll use that if they're similar faces, and we'll treat them as the same person. So we don't actually train the neural network ourselves, but we use the neural network to take our pictures, convert them to our vectors, and then we compare the vectors. And if the vectors are similar, then we assume they're the same person.
Yeah.
And one thing I have seen is, which I find quite astonishing. I don't know if I'm going to find some examples, but they do go back quite a bit in time. This is my daughter. I'll sort of scroll back in time and might find some quite old pictures, and it does. It still recognizes them up to, I don't know, about 5 years old or something like that. They sort of fail a bit when they get to babies, but maybe that's expected. Tom.
Once a face has been recognized and possibly even confirmed by the user, can the EXIF data be written directly into the image file itself?
Not currently, no. But at the start, I mentioned that this application is under intensive development, and there is talk for doing exactly that, to actually add the facial details actually into the EXIF data. And there's other things to add into the EXIF data as well. You can have things like marks out of 5, how good this picture is. There's a whole bunch of stuff you could actually put in EXIF and actually use in other applications if you wanted to.
I perhaps cynically perceived that Google Photos, which was free and pre-installed on all Android phones and was automatically out of the box uploading images, backing them up to the Google Photos in the cloud. I think I certainly feel I may have been a useful idiot for Google in giving face recognition and building recognition and locations. And once Google had trained its model, it switched the free component off. It's now chargeable. But what I fear is that once one has added location information and whatever, if one then downloads those images from Google Photos, the EXIF, it may not have been written to the EXIF. I've not tested this recently, but even if it is, they may strip it out in the future so that future generations who I may be trying to create an album for will not benefit from the hard work I've made of saying that this was Alice's wedding or this was whatever it was. And so what I want from my photo album is a lasting legacy
Mhm.
It looks to me like this particular solution gives something that's lasting in that it can be shared not only to current generations, but the data is going to be there and available to all, same images, and this album could last 100 years.
Yeah, so some interesting points to tease out of that. So in my case, I'm running immich on the server in my cupboard next to me, and that's because because it's fun, I can do it. But of course, if you wanted to create a legacy, if you just talked about it, you could run immich on a hosting provider, as just like any other websites. You could pay some money, they will host the application for you, so you don't need to do it in your cupboard, but you still got control over it. So if you're thinking about legacy stuff, you probably wouldn't want to host it yourself because unless your children are going to pick up management of that. But you could run this application or get someone else to run this application for you. The second thing I'll say is specific to Google Photographs and EXIF information. Now, Google has an API that allows you to download pictures, and that's the API that gets used by various applications. And the EXIF information is stripped out of pictures when you do that download via the API. But what you can do with Google Photographs is a thing called Google Takeout, which is to request Google all your private information. And you get presented a form and you can say, right, I want to be emailed a Google Takeout file just containing my Google pictures. And then you get emailed this massive zip file that actually contains all your original pictures with all the EXIF information contained in it. And then you can use that to upload into immich and maintain the location information. That's what I actually did when I moved from Google Photographs to immich. I used Google Takeout. Any other comments before we go on to backups? Well, we're covering quite a lot of different topics today. Okay, so let's go back to my slides. Configuration backups. So if you're using any kind of storage system, you do need to back it up, obviously. And I think photographs have a particular additional value. So although they're small and low financial value, it's not as though it's giving you access to your bank accounts or something like that. They are still quite valuable from an emotional point of view. You don't want to lose them. You don't want your disk to get corrupted and then you've lost everything and so on. So backups are important. Now I've recently changed my backups to using a tool called Restic. Now Restic is actually pretty neat. If you're used to things like the Apple Time Machine, it works in a similar sort of way. What Restic does, it takes a series of snapshots of your file system. And each snapshot, instead of being a full backup, is just the difference between the previous one. So if you've done a Restic backup of all your images, you add one more photograph to immich, you do another Restic backup, that new snapshot will just contain the new image that you've added. And then when you do a restore, of course, you restore all the total of the snapshots. And so this is kind of quite an important technique for backups, because let's say you accidentally delete all your pictures in immich, and before you manage to stop it, a backup kicks off. That backup is now could be empty. But if you take very much a snapshot point of view, okay, the very latest snapshot will have no images, but you could go back to the previous snapshot and then still restore all your images. So that's what I do now. I've got a Restic server running on my home network, and I back up actually all my machines to it. And it's a client server mechanism. So you've got a REST client, which you run on all your different devices, and that pushes updates to the server. As I say, it's snapshot based. So each backup is really the difference to the last snapshot. So once you've done the first backup, daily or hourly backups, actually quite quick. And what I've decided to do is to keep 7 daily backups, 5 weekly and 12 monthly. So you can go back to, yesterday's backup or the day before's backup or last week's or last month's backup. So it's very similar if you're used to using things like Time Machine, it works in the same way. Now we have to do something a little bit special for immich. Now we're running a Postgres relational database. We've talked about that. And Postgres actually uses a file system to hold all its tables and such like. And you can't just go and back this up because these are live files that are constantly being changed. If you do back up the file and restore it, you're going to end up with a database that doesn't start. It's going to have corruptions in it. So the way to back up relational database or any kind of application that's kind of live and running is, first of all, you dump that to a file. So we've got this command here, Postgres dump, that actually creates an export of your database. So this application will actually freeze the database. It'll export all the tables to a file. And then we actually do a backup of all your original images that you've uploaded, plus this dump file. You don't bother backing up the database itself. And then should your server get corrupted, the way you'd restore it is you'd reinstall immich. You'd use this file to repopulate your database, and then you'd start your application. So, it's a two-step process. You can't just go and just do a backup because you've got a whole tree of files which are constantly being changed. And if you do a backup, you're going to get this skewing effect, and your database will not open once you restore it. So any sort of backups, you were quite careful with applications that are currently running. And this is what it looks like. Again, it's mostly a command line tool, but you've got various user interfaces. And if anyone's interested, we can actually have a look at it. And you can look at all the snapshots for immich, and we can see we've got snapshots going back a few days in this case. And this total size here is actually the total size of all the snapshots. So this particular snapshot will be tiny, but if you were to restore it, actually look back in all the previous snapshots and restore the files. Yeah, so let's actually look at it. Since there were some questions on backups, let's see if we can share my terminal again. So I can do Restic snapshots. And we can see all the snapshots. You can see here, this is the host that I'm backing up and the path. So I've got lots and lots of different snapshots. And we can do things like, we can list the contents of a snapshot if we want. Might take a bit of time. It's not instant, but I've picked a big one, of course, typical. So there's a list of files, and you can do things like you can do searches for search for a particular file and then restore it and so on and so forth. So it's a nice little snapshot backup application. And I think it works quite well, particularly with immich, because you really want to have this history of the backups, because you definitely want to protect yourself against an administration mistake and you actually delete all your pictures. All right, anything on backups? David?
Yeah, so I mean, in the past when I've looked at photo apps, the storage of the image files is separate from the indexing.
Yes.
So it's an overlaid organization.
Yeah.
So I guess my question is that the architecture here, or are the images integrated into the indexing?
So what we have in the file system, library, we got the path library upload, and that contains all the original images untouched. But we've also got library, we can see it there. We've also got a thumbnail directory, which are, smaller versions of the images. We're not going to back that up because when we start up immich after a fatal error, we'll just allow the thumbnails to be recreated.
Yeah. So your backups would have to back up to the two components, wouldn't they? The image library itself and the sort of the mapping that I guess immich does.
Yeah, so I back up the original pictures in the upload directory and the export of the database.
Okay.
Export of data contains all your definitions of albums and all such like. And you start up immich with those two things, restore the database, and then immich will then go through and recreate thumbnails and so on, and recalculate the facial. Oh, it actually won't recalculate the recognitions. That's in the database. But anything which is ancillary, I think there's like two different resolutions of thumbnails, and there's for videos, they've got the first frame, I think, on the videos. We just let immich recalculate those. In fact, I'll show you the job tab. Go Google share. We go back to immich and we can go into administration. We can go to jobs, and these are all the jobs that we've got. So we've got a job to generate thumbnails. We don't need to back those up. We just rerun this job. We've got a job to extract the metadata, the EXIF information.
Oh, okay.
We've got jobs for the smart search, the object detection, duplicate detection, which depends on the smart search. So whenever you upload a new picture, these jobs are automatically triggered and queued and then executed. So, new pictures after, a few seconds will have be able to participate in searches and facial recognition.
So what file format is used for the image store?
The original images are just the original JPEGs or whatever they are.
Oh, so also, so it's independent of the actual format. It could be CR3s or I guess
that upload directory that I showed you is the original images that you added. So if you upload them JPEGs, there'll be JPEGs. If you uploaded them as PNGs, there'll be PNGs. If you upload it as these web formats or Apple formats, then there'll be those formats.
Can you handle the raw formats as well, like CR3?
Yep. Raw formats. I've not explored that myself. I don't use raw, but I have seen mentioned of the raw formats, and it'll extract the thumbnails from raws in sorts of ways.
Now, one problem with EXIF, cool, stretching my brain back, the time information doesn't actually carry the time zone information.
Oh, it does.
It does now, does it?
It does, yeah.
Oh, okay.
Yeah,
Well, the rest of my question is moot.
Yeah. I had to look at EXIF when I was looking at 360 pictures.
Right.
So yes, it's annoyingly, it's got the timestamps in several different places in the EXIF structure.
So they're all carry the time zone as well.
There's at least one that has a time zone.
Oh, okay.
Yeah.
My question was then going to be if you've got something that doesn't have is it possible to sort of construct that from location information?
I wrote an application to do exactly that.
Oh, okay.
So since you asked, I have looked at 3D pictures, and particularly having a sequence of 3D pictures to upload to I forget the word, but it's a Google Street View, to upload to Street View. And my 3D cameras didn't have the timestamp in it. So what you could do is record the GPX of your walk and then load up a little application that I wrote GPX file and your pictures, and then we would work out the location and the timestamps are based on the timestamps. So do timestamp
Right.
comparisons and add the locations of the pictures.
Okay.
And of course, in Image, you can go and edit the timestamp if you want, or the location.
So presumably, well, okay, not presumably. So if you wanted to do process some pictures, you can go to those directly independent of Image, and as long as you don't move it, then Image isn't gonna.
Yeah, Image, the phone app has got some simple editing, functions on it, rotate and flip and that sort of stuff. And the developers seem to be expanding on that all the time. But essentially, Image is not a photo editing tool.
Oh,
You want to do that outside and then use Image as a photo organizing tool and a sharing tool.
right. So I mean, so a person asked earlier about Lightroom, which is
Mm.
that. I mean, that's a professional editing tool.
Mhm.
Yeah, I don't use. I use Darkroom now. So, but they're basically you'd be able to access the individual images, process them.
Yeah.
I guess as long as you don't move them and don't change the file name,
Yep.
it's
Yeah, you can always download the original images. So pick any image and then you can download, and that will get you the original image.
Oh, okay, and you process from there. Right.
Yeah.
You can replace with upload as well. Okay, oh, that's cool.
Yeah, there's a few things. I think, yeah, it's under a heavy development. So if you're going to use this, you really kind of engage what issues are being worked on and stuff. And it seems to get a new release every couple of weeks, something like that. And this, just for your amusement, as we're coming to the end, I was away last weekend and I came back to pictures of a wretched heron eating the fish from my pond. Tom, you've had your hand up patiently there for a while.
So sorry, yeah, I guess I'm building on what David was saying about where the data, the information is stored. One of the things that, because coming back to the legacy thing, I've tried to make my photo library as compatible with any other person's library or any other library system I may move to, and of course future generations might use. So I do like the EXIF, storing all my data as much as possible, write it into the EXIF. And I know that some libraries balk at doing that, and some users may balk at doing that because of course they don't want destructive editing, but I prefer to write the data into the EXIF themselves, because if someone else downloads the picture and they're using a different photo library manager to me, they can still read where it was, who is in it, the face, all the face information, the title, the captions, and any additional tags. And it sounds like this app is moving in that direction, the ability to save the face recognition in the data. But
I think so. If you look at this to actually switch into this, I would suggest I put it in the references at the end of the slides. Just having a look at the GitHub repository, the issues particularly. They're actually quite interesting because different people are discussing features. We should have this, we shouldn't have that. But I know one of the core not building blocks, but core principles of immich is that the original picture is always maintained untouched. So you back up the database and then you can, retrieve any kind of additional, the facial stuff from the database. And I did see discussions about actually being able to, almost export the original picture, but with all the extra metadata that you've added manually added to the EXIF. But I don't think that exists quite yet. Okay, so I think we've got to the end of our slides. Anything else anyone else wants to mention?
Pete, yes, Neil.
Yeah.
Something on that job listing, are all those jobs generated by you? Are some of those jobs or are they inherent? Is it just a listing of pre-created jobs that are within the app?
Yeah, so when you upload pictures, a job is automatically created for
Yeah.
the pictures that you've uploaded. Um, so that happens automatically. You upload 10 pictures and you get 10 jobs created to analyze a picture. But you can actually kick them off as well. You can restart them, you can refresh them. For example, you might change the neural network configuration for facial recognition. And if you do that, you have to rerun all the facial detection for all your pictures from scratch, which might take some time. So you can actually manually start them if you wanted to. But generally, you leave this stuff alone. You upload a picture, and these jobs are created for you, and they work through, and then they go to completion.
Okay. Yeah. Thanks. Yeah. Yeah. I wasn't quite sure. Yeah. What the balance was.
Mm.
Many of them were whether it was a sort of, if you like, user developable or obviously you can interact with it. But okay, lovely. Thanks.
Yeah, so hopefully you can see what I tried to do is to talk about one particular application. I'm not particularly selling it. I think it's quite a nice application, but I thought it was interesting because it touches on several different aspects of things that we've talked about before. We touched on networking, we talked about containers, we talked about AI and the neural networks that are in there. And immich is kind of quite nice because it brings all these sorts of bits and pieces that we talked together into one place in a bit more realistic environment. Any other comments or thoughts before we sign off?
I've got one more. So,
Yeah, you fire away again.
this thing that you brought up about active relational databases and corruptions, is it, I obviously worked with relational databases a fair bit in the past, and we had corruptions then, but then I was not running. And as you know, I don't know that much about computers, but is this something in which I should be actively concerned about any relational databases I've got now? Because when I do backups, I just use standard backup mechanism. And I don't know, I haven't had to restore anything for the last 7 or 8 years. I have no idea whether there's anything that I'm actually currently dealing with which I would find would be corrupted.
Well, the golden rule of backups is you test them.
Offer, right?
I can tell by David's face, he was about to say exactly the same point. Yes, you need to test your backups. But really, the principles of backups is anything that is open, that has open files that are being changed. A relational database is a classic example.
Yeah.
But you could be, opening up, just spreadsheets or word processor, backing up something that's active. There's a fair chance that backup is not that useful because depending on where your application was and writing to disk and where the backup's reading from disk, you could have a duff backup. So you do, in general, with backups, have to be very careful about backing up anything that's currently running.
Yeah.
And there's lots of different techniques to back up relational database. I've just done an export because it's a relatively small database that's fairly quick. But for commercial organizations, they will have a snapshot type system. Every 10 minutes or something, they create a new snapshot of a live database and keep doing it. And then the way you restore it is actually you take all these snapshots and you roll the database forwards, absorbing one snapshot after another until you're bang up to date. So you don't have to do an export. Sometimes that's not feasible with very big databases. There are other techniques, but you just can't just back up a live file system with a running application.
Now you've mentioned that, I vaguely remember people talking about that rolling up thing.
Yeah.
Yes. But yes, okay, thanks.
Ray.
Yeah, you mentioned 3D cameras earlier. Any thoughts, recommendations, or is
No,
that a subject in its own right?
yeah, I've got it here somewhere actually. I don't know if you can see it. No, I've got this little tiny. It's got two lenses, one on either side, and the idea is just hold it up and press the button, and you take two pictures at the same time. The device itself stitches them together into a 360 picture. Now, this one here is a low-end device. And the reason I got it was because it was being sold incredibly cheap on Amazon as a returned item. You know, it said Amazon said something like scratches on camera or something like that. I thought, sod it. It was only like £30 or something, so I ordered it. And what they meant was scratches on the box. So the camera itself was fine. So I've not heavily into 360 pictures. I've got this one because it's going cheap. I think it's a 4K resolution, but that is quite low resolution for a 360 picture, you know, because you're taking a complete picture and the actual, you know, the quality isn't brilliant. But I like it because it gives you a much better feel for the location you're at, you know, particularly wide open outdoor places. It works quite well. But no, I'm not particularly 3D person. I just got it cheap.
Okay, is that a fisheye lens on each side then?
It is, yeah.
Yeah. Okay.
Yeah. You can see it better. Edge on just sticks out. Any other points to raise? We've got some chat. All right, no questions in the chat. Nothing else. If there's nothing else, I suggest we call it a day, and I'll publish the recording up on YouTube as usual. And let me know if you've got any brilliant ideas for talks, and particularly if you want to volunteer doing one.
Brilliant. Thanks, Peter.
I hesitate making a suggestion based on the very last sentence. Actually looking at backing up, backups.
Oh yeah, that's a good idea.
Yeah, because that's something that, I mean, people are obviously becoming increasingly concerned about, right? Not only preserving the data so you can use it, but also so people who follow you can use it. Yeah.
So when are you planning to do that?
That's why I hesitated. I use rsync. Because I use Linux, I just use rsync and do stuff manually.
I used to. The problem with rsync is not really naturally a snapshot type system. So if you delete the files, unless you stop rsync, then you delete it on the target. Or, you know, depending on what options on rsync you do, your rsync becomes a total sum of all your deleted files, and you store it and have to delete them, or you lose some. So
I do sort of grandfathering.
Oh, okay, yeah.
Right. So hopefully you catch the error. So my approach is to try and keep things really simple, and it's the Unix model of lots of small, simple tools.
Yeah. No, I
agree.
I mean, I've gone to Restic, and it's just a one command like rsync, and I just run it on all my little servers and my Mac desktop and whatever. So I'm quite liking it.
But I find back in time is very good.
Yeah, I mean, one thing I found is a lot of the backup programs are specific to an operating system. You know, so you'd have a Windows app which is really good on Windows, but it's not available for Macs. You've got Mac Time Machine, which is great for Macs, but it's not available on Windows and Linux and such like. So that's why I went to Restic, because it is cross-platform. You know, you can restore files from any device that fails on any other device. Anyway, that's
sorry, can we just confirm the next meeting's on what date was it?
It was on the slides, 19th of November.
Oh, it is right. Okay, then.
Yeah. All right, let's close it down there. Thanks for attending. I'll see you next month.
Yeah, thanks, Pete.
All right.
Thanks all. Yeah, thank you, Pete.